Hi everyone, my name's Derek and I am here to give you a quick tutorial on churn analysis using logistic regression. Now this is a video series on marketing analytics, so please check out my other videos on marketing analytics when you can. So I'm just going to start out with what is going to be covered in this particular video tutorial. Firstly, I'm going to tell you a little bit about what churn is and why it is so important in the marketing profession. Secondly, I'm going to tell you a little bit about what is logistic regression. And thirdly, we're going to look at how logistic regression builds a churn model through using training data sets, in which after that we can also use this model to score on a data set that doesn't have our predictor variables. Now, let's begin. What is churn? You hear this word about churn. Is it turning? Yes, it's something like turning. In marketing, it also means customer attrition. Now, this means that when your customers stop doing business with your company, so for instance, if let's say a customer were to change service providers, were to change products, company loyalty, and that means that they have left the company and means that the company needs to start identifying who these customers are. Okay, so identifying these customers is important, especially if you have databases of customers who have left in the past, because trying to retain your customers would definitely be cheaper than actually acquiring new ones, because acquiring new ones is usually you need a lot of marketing effort. But if you can keep your customers loyal to the company, it would be much easier and cheaper in that sense. So how do we stop churn then? Basically, if we knew that there is a segment of customers at the risk of churning, then most probably we can proactively engage them with special offers instead of simply just losing them and letting them slip by the cracks. Now we do this by finding out, let's say we have past churners who have left. We want to find out why these people left our companies. And when we can ascertain some of the variables or predict some of the variables of why these customers left us, then we can use this to predict our current customers and stop them from leaving if we know that their probability of leaving is high. So once we know who these churners are, we can then set strategies in motion to ensure that the higher probability of churners can be retained so that we don't get them slipping through the cracks. There are two types of churning. One are the passive churners and the other one is the active churners. The passive churners are mostly those people who probably have problems with the company and they decided not to review their membership, or their membership has already finished a contract and they decided or they forgot to renew their membership. Whereas the active churners, who are also the people who are actively engaging with the company, but because of some dispute, they feel that it is no longer viable or even profitable for them to continue service with the company. So next, we're going to look at how logistic regression is used for us to recognize these churners, and we can create a predictive model on how we can find out what are the cases of churn. So firstly, I'm going to cover what is logistic regression. Basically, logistic regression is used to estimate probability that a particular outcome will occur. And I'm going to discuss with you a little bit about this thing called odds ratio, which is used widely in biostatistics, but we can also apply it here in marketing. Then I'm going to look at when and why do we use logistic regression. Now, logistic regression is used when your predictor outcome is categorical in nature, as opposed to multiple linear regression where the predictor outcome is continuous in nature. And I'm going to cover a little bit on that. There is a theory behind logistic regression where we have to look at how we assess the model, how we assess the predictors, and how we use it for testing and scoring. Simulation will be done in this video tutorial. And finally, I'm going to show it to you how this can be simulated on an example of a telco customer churn dataset. Right, so let's begin with odds ratio. Now, odds ratio is basically the dependent variable, as I mentioned in the logistic regression. That means we are looking at the odds of a favorable outcome against the odds of an unfavorable outcome. Now, to put it very simply, I'm just going to show you a 2x2 table on instances where millennials bought something and millennials didn't buy something. So this is a 2x2 table, as you can see here. Now, how can we calculate the odds ratio from this? Very simply, take the cross product of the buy and the didn't buy, and then you know that the odds ratio here is 25 times 30 divided by 50 times 2, which is 7.5. What this means is that your millennials have a 7.5 chance of buying against a non-millennial. So a millennial would have 7.5 times higher chance of buying something than a non-millennial. Okay, so that's a simple interpretation of odds ratio. I'm not going to go very detailed into the mathematics of it, but more mathematics is coming along. So when do we use logistic regression? As I mentioned, logistic regression is used when the outcome predictor variable is a categorical predictor variable, and the target variable, the target variable, outcome variable is categorical, and all your other predictors can be continuous or categorical. Much like your multiple linear regression, if you have not seen multiple linear regression, I have a video series that talks about multiple linear regression. You can also look into that. That is when your dependent variable is continuous in nature. But for this one, we are concentrating on your dependent variable being categorical. That's where you use logistic regression. Now, it is used because your categorical outcome violates the assumption of linearity when you do the normal multiple linear regression, okay, which is basically the one of the 5 classical linear regression assumptions, and it violates the assumption of linearity, which is why we need to use logistic regression. Now, if you're dealing with one predictor, the probability of an outcome happening will be 1 over 1 plus the exponent of your indicator beta values. So the outcome is we want to predict the probability of an outcome recurring, where the beta naught and the beta 1, my apologies, beta 1, can be thought of in much as the way of multiple linear regression. And I'm going to show you a little bit of mathematics later, but don't worry, it's not too difficult. The normal regression equation forms the part of the logistic regression equation like this. Now, if there's several predictors, which is like a multiple linear regression, the same thing happens. It's just that now we expand the top part of it with more predictor variables. Yeah. The difference is the multiple linear regression form part of the logistic regression, and the part of the equation expands now to accommodate additional predictors. So what do I mean by how do we compare this to a linear regression? Now, if you notice in this graph, the linear regression is a straight line relationship. Yeah, X and Y, 1-to-1 straight line relationship. But logistic regression is a non-linear relationship, which is an exponential relationship, which is why it is a predicted probability rather than an actual event happening. So for instance, for example, if we want the probability of an event happening, then it will be E over 1 plus E and all the predictors as the exponent. Which is why if you log this particular equation, you will get the actual multiple linear regression. Now it's actually pretty simple. The log of the probability of the odds ratio is actually getting back to the probability of an event happening, which is why I say you transform this, the logistic regression, into a form of linear regression. A little bit of maths, but not to worry too much about it. It's just for those people who feel that they want to find out a little bit more. You can use this slide and figure it out later on yourself. Okay, so how do we then assess the predictors? Now, just like multiple linear regression, you use the t statistics for your assumption of whether the predictor is significant. But in logistic regression, we use the wall statistics, which is B over the SE of the beta. And we also test against the null hypothesis of not equals to 0. Now, it can be biased when the B is large. However, we try not to use this, although some people, experts, say that wall statistics is actually a good one. But we can also look at the likelihood ratio statistics when we want to assess each predictor variable. But I'm also going to show it to you as well. The better one that to use, first we find out whether it's significant. Then we want to find out how to interpret each of the variables in the model. And we use this by looking at the odds ratio or the exponential of the beta, which is odds after a unit change in the predictor, the independent variable, over odds before a unit change in the predictor. Now, what this means is that odds of exposure, if it's equals to 1, then it is the same for the cases of control and non-control, which means that there's no association between a certain outcome and exposure. But if it's more than 1, then your case of happening or predicted probability in that case will be a greater in terms of the probability than the other controls, which means than the other membership. Okay, but if it's less than 1, then your odds will be lower than the actual predicted membership. So what this means is it indicates the change in the odds resulting from unit change in predictor. So if your odds ratio is more than 1, your predictor goes up. When your predictor goes up, then your probability of the outcome occurring for the target category will go up. But if your odds ratio is less than 1, then your predictor for the probability of the outcome occurring in the target category will be lower. Okay. Now, a little bit more maths. Again, please do not be overwhelmed by these maths. This is just theory for me to assess and tell you about the theory of logistic regression. When we want to assess the model, there are a couple of things that we look at. One is the log likelihood statistics, so we call it LL for short. This is like the residual sums of squares in multiple linear regression. And it is an indicator of how much unexplained information there is after the model has been fitted. Now, obviously, we do not want this to be high, because if it's high, then it means there's poorly fitted statistical models. What we want is the log likelihood to be as low as possible, and to make sure that the fit values like Cox and Snell and also the categorical R-square is low. Now, there's one here which I did not list down. It's called the Hosmer and Lame-Shaw. That one is also something that we want to make sure that is low. So, take for instance, if you want your data to fit the model, that means that the observed and the predicted needs to be together. That means it's a good fit. So, if your chi-square is high, means that the observed and predicted is not well fitted. So what does this mean? To get a good fit for your model, you need to make sure that these values are insignificant. That means they are not significant. Then it will show that you have a good fit. Design issues. Logistic regression is sensitive to problems of small sample sizes and multicollinearity, as similar to multiple regression. So please check for this next time when you do collect data for logistic regression. Logistic regression has two types, as I mentioned. If your target variable has two categories, that's what you call binary logistic regression. If it has more than two categories in the dependent variable, then it is called multinomial logistic regression. For this tutorial, to keep things easy and simple, I'm just going to concentrate on the first one, which is binary logistic regression. Okay, what if you have two models and you want to find out which model is better? Well, you can assess the changes in the model by looking at the different comparisons of the log likelihoods, because you will get the log likelihood. So take the log likelihood of the two and then compare it by using your chi-square test. Right. So what are some of the methods of regression that logistic regression has? Firstly, there is the force entry, where you just put in all the variables that you need in simultaneously. You can do it in blocks, in hierarchical. Now this is a good method, but this one you will have to follow a theory. Or you can do it stepwise, which is one block by block. And it can either be forward or backward stepwise. However, this one is about you understanding what you're doing. For this video tutorial, we're just going to focus on the force entry, which is the easiest one to do. Okay. Because we are doing a predictive model, you need to split the data into training set and testing data set. Or we also call it the training data set, or we call it the scoring data set. Now, the training data set is the one that we're going to use to build the model. This is the one with the dependent variable, with two categories. Of course, we're talking about binary logistic here. Now, once the model is built, the new data set without the DV is when you test the model inside, and we call this the scoring. So when you score that new data set with the tested model, then it helps us to predict the outcomes based on this thing we call confidence. And I'll show it to you in the example. So remember one thing though, the model is only good for that period of data set. You might have to continually remodel and test the accuracy of the model consistently as new data comes in. The more data you have, the more robust your model is. The more frequent you redo your model, the more higher probability or higher accuracy you have in your prediction. So now, what I'm going to do is I'm going to use this telco churn data, and I'm going to show you and simulate for you how you can do this. So let me just explain to you a little bit about this data set. This data set actually has 7,000 over records, and I've split this data set into two. One called the testing, which is about 70% of the records, which is 4,930 records, and another one is the scoring, which is about 30%, 2,153. So I'm going to take the model built from the testing, and I'm going to score it on the scoring data set without the cases of churn. That means there's no DV in the scoring. So the variables that I'm going to be using here is, of course, the churn, which is only available in the testing. And then in both the testing and the scoring, they have the tenure months, which is how many months that the customer has been as a customer with the telco. What are the monthly charges that this person have? That means the average monthly charges. Whether this person uses a phone service, which is a binary category, yes or no. And there are three categories for internet service usage, whether this person is a no, whether this person uses DSL, direct service line, or whether this person uses fiber optic. So what I'm going to do here is I'm going to build the model with the training data set. I'm going to interpret the model, interpret the assess the fit, and also assess the variables, as well as predict the churn on the scoring data set. All right. Okay, So I'm going to bring you to a quick simulation on how to do logistic regression, as I mentioned, with the data set of telco customer churn. So I have my telco customer churn here, and I'm going to be using only a couple of variables. I have a lot of variables here, and you notice that I have my DV here, which is churn, which is just basically yes or no. So this one, as I mentioned just now, I have about 4,930 records. Yeah, 4,930 records. So I'm going to show you how to do the logistic regression. Now, because this is two categories, therefore, I'm only going to be doing a binary logistic regression. So we go Analyze, Regression, Binary Logistic. If you have more than two categories, then you'll be choosing the multinomial logistic. So binary logistic. Now, I've already set in here, and I can just redo it for you. Dependent variable will be the churn. And then my covariates, or the variables that I'm going to be looking at, will be tenure in months. I'm going to put in whether they have a phone service, internet service, and monthly charges. All right. So these are basically the variables that I'll be looking at. Now, there are three things I have to do here. One, categorical, save, and options. I need to first identify what are my categorical variables that I'm putting into the model. So category, I am basically saying that phone service is an indicator variable, and I am looking at the reference category, which is the last category. So for those of you who are in that category, so I'm looking at the indicator change. And then of course the internet service, again last category being the last category of the variable as the reference category. Okay, so now I'm going to continue, and then next I need to save. First, I need to save the probability and the group membership because I just want to see whether or not there is a match. I'm looking at also saving the model because I need to export the model to a file which I can use later on to score my data set. So I'm browsing. I'm going to call this my telco customer churn. Actually, I have saved it already, but just make sure you save it under what do you call this, a file which you can quickly retrieve this XML file. So you can save this XML file, and I'll call it the customer telco customer churn model. I'll save it, continue, and then options. I want to make sure that I look at the classification plots because there's something I want to talk to you guys about. The Hosper and Lameshaw goodness of fit, which I mentioned to you just now, and also look at the confidence interval for the exponential of the betas, right? So continue, and that's all I need to do. I'll just press OK. So once you have run, you get to see that these are the prediction of the outcome, or the what you call this, the probability of the case being classified in the target category, which is churn. You notice that this one is 0.48%, which means that there is a 48% chance that this particular case will be classified as a churn. So no, and then the membership here is no, which means that it is less than 50%. So definitely no. Only the ones where you see that it is more than 50%, you see a yes. You see this? Yes, more than 50%. Anything that's less than 50%, they will not be. Now, for example, like this one here, although the observed is churn is yes, but the prediction for this person to be predicted in yes is given a 0.35. So it is less than 50% that this case will be classified as churn. So therefore, in the predicted group membership, it becomes no. I hope you understand this. Now, I'm just going to take you through some of the results. Okay. So firstly, you want to look at here is the categorical variable changes, 1 and 2, the parameter coding. The important thing to see here is the last one. Hold on. Coming down here, classification model. Okay, so few things you want to see. First, the model summary. Okay, so the model summary looks at Cox and Snell. Maybe I'll just go through the slide with you. That'll be easier. Yeah. I've shown you this. I've shown you this. Okay, let's go through this one. So, goodness of fit. All these values are insignificant, which means that there is no significant difference between the observed and the predicted values. So if you notice that it is 0.244 and 0.357, which means that there is no significant, that means the values are insignificant, right? Now, and then if you look at the Hosmer and Lim-Shaw test, it is a significance of 0.161. Now, what this means is that there is no significant difference between the observed and the predicted values, meaning that the observed and the predicted values are almost the same. That means that your model is quite well fit. So there is goodness of fit here for you. So continuing on with our results, you can see that the classification table here, we have at least about 3,310 correctly predicted as no and 594 correctly predicted as yes. Okay, so this model actually is not that bad, because if you look at the current percentage correctly predicted is about overall 79.2%, which is really, really, really good. Right, to move on, I want you to look at some of the variables in the equation. So as I mentioned to you, I want you to look into the variables, and then I want you to look into the wall statistics, and of course the significance, and then the exponential B. So there are some explanation for you to look at. Keeping in mind that our target membership is 1 for churn, and we're only going to be looking at the significant variables, which means that we are only going to be looking at, we're only going to be looking at tenure months. We're not looking at monthly charges because it is insignificant, as you can see here. We're going to be looking at phone service, internet service 1 and 2, and that's it. So what do all these mean? So for tenure months, the significance or the exponential B is 0.953. Now, this is less than 1. So what this means is 1 extra month with the company will result in 0.95 times less likely to churn, because we are looking at the target membership is 1, right? So the odds of churning decreases for these for the cases by 1 minus 0.1953, which means that the more months you have, then your chances of churning decreases by 4.7%. So which means loyalty, isn't it? Then we look at phone service. Phone service is a 1.873. So if you transform this into odds ratio, again bearing in mind that our target membership here is 1, that means for churn, so it's higher than 1, so we don't have to minus take a 1 minus something. So therefore, the phone service users are 1.8 times more likely to churn, which means that the odds of churning increases by 80% if you use the phone service, which means that probably the phone service is not so good, and therefore people feel that, they want to churn. Then there is, of course, Internet Service 1 and Internet Service 2. This is multi-categorical for the predictor variable. Now, Internet Service 1 is those people who uses DSL, and you have an exponential b here of 0.95. So with this one here, exponential b of 0.95 here, this means that, 0.095. This means that the DSL users are 0.095 times more likely to churn, right? Which means that the odds of churning decreases by 1 minus 0.095 times, which is probably about 90% if you have the DSL. And for Internet Service 2, again, it is less than 1 for the exponential b, so you have to take a 1 minus something because of the target membership is churn. The fiber optic users are 0.4243 times more likely to churn, which means that it decreases 1 minus 0.243 by a 75.7% of chance of churning. So you see that this means that if, I know that this is a little bit confusing, so the easiest way to think about this is, if it's more than a 1, make sure that you just use whatever the percentage is left after you take away the 1. And you need to know very, very clearly what your target membership is, because your target membership will determine whether you minus a 1 or just take the actual odds ratio. All right? So this is where we have decided that our variables are. We're going to stick to these variables still. And next, what we're going to do is we're going to show you a demo on how this model is going to be used for scoring. Now, before we go into the scoring of the model, let me just show you a little bit about what the classification plot which you have created from the logistic regression tells you. Now, you notice that there are a lot of cases on the lower side and less cases on the higher side. What is our target variable here? Our target variable is yes, which means that the more it overshoots 50%, that means the higher it becomes yes. Now, look at the cases which are classified as no. Quite a number of the no's are here, but there are a couple of yeses as well. Okay, which means that this model classifies the no's quite well, but when it comes to the yeses, it also is good, but not as good as classifying the no. So you still have a lot of information that you can use here when you're talking about classification. However, if you notice that the yeses are also quite high on the Y, and here on the no's on the left. So the predicted probability membership for the yes and the no's, as long as you see no's largely on the left side and the yes largely on the right side, you will know that this is actually a very, very good model. Yeah, because each symbol represents 20 cases. Remember, we have over 4,000 cases here. So this is how you read the classification plot. Those that has correctly identified as yes and belong to the yes, this is the probability that you get for each of these cases. And the no's, these are the probability that you get here. So, which is correctly identified. The ones that are not correctly identified would be the ones that are yes and underneath the no domain, and the no underneath the yes domain. So these are the ones not correctly identified. So the next one I'm going to show you is how we're going to use this logistic model now to score your scoring data set, which is the data set without the dependent variable. Hi, So you remember just now we created the model. So now I'm going to use the telco customer churn scoring dataset. And you notice that the dataset is almost exactly the same in terms of its variables, except it now does not have a dependent variable. And I'm going to use the model that we just created to score onto this particular data set. So I'm going to show you what to do. Now, firstly, utilities, we're going to go to the scoring wizard. Make sure you find the model that we created just now, called the telco customer churn model from the testing dataset. And once you've got that, make sure your predictors, the target variable churn is the same, and the phone service, the internet service, 10-year months, monthly charges, all the predictor variables are the same as well. Because if they're not the same, you will have to do some sort of adjustment to the variables to ensure that the variables sync to each other. Now, next. So the next thing you need to look at is, once you have decided on what variables you're using, you also need to make sure that the measure is correct, the role is correct, and also the type is correct. They're all numeric fields in this one, so it's no problem. Next, make sure you have the confidence predicted value saved, because we're going to create these new variables out. Probability of the predicted category, and you want the probability of the selected category. Now, of course, this selected category here, it's a 1, which means that we want to find out what is the probability of this case being predicted in the churn membership. So finish, and you notice that you have confidence here, and of course the predicted value, predicted probability, and selected probability. So first off, make sure that you align in descending order by confidence. So all you need to do is just click on confidence and go to sort descending, and you will notice that all your cases are now in descending order of confidence, and the lowest descending confidence obviously will be 0.5, which means that it has not been anything less than 0.5 means that it's not there's no confidence of the classification. All right, so it's definitely either a 1 or a 0.5, which is the lowest. Okay, all right. So finally, we can now see the result of our model and the scoring of the model. Okay, so as I mentioned just now, make sure that you sort the cases in descending order so that you can see the confidence the column from 0.99, in some cases it could be 1, all the way down to a 0.5. So I'm just going to give you a bit of an interpretation. Again, bearing in mind that the target membership here is 1 for churn, meaning to say that if you look at these two cases here, case 2104 and case 2105, and I'm going to explain to you what these cases mean in terms of the predicted probability and selected probability. So in case 2104, you notice that the predicted in no churn, yeah, because you see a predicted value of 0, is at a confidence of 52%, which means that there is a 52% confidence that it was predicted in no churn. That means that if you take the 1 minus of the 52, because remember we are talking about 1 for target churn, the selected probability, which means what is the probability of this particular case being predicted in to be predicted in the churn category. That means that it will have a 48% chance of churning. So this case has a 48% chance of classified as churn or being churned. in terms of selected probability. Now, if I look at case number 2105, the predicted churn confidence is 52%, which means that if you look at the predicted value, this particular case has been predicted in the category of churn. Do I need to minus this? No, because if you notice that it is the same as churn and churn, therefore the selected probability, which I remember just now I chose that my target category is churn, that means this person has a 52% chance of churning in the selected probability. Now, I know that there is a lot for you to take in for this particular video tutorial. I really would like all of you to take your time to go through this video tutorial, because it took me quite a long time just to understand and also explain it in such a way where people will understand as well. You can email me if you have any questions. I will be happy to help you. And logistic regression is a great way of trying to find predicted membership groups. Now, churn analysis is also a great way for you to decide who are your vulnerable cases and what are the variables that are important for you to ascertain in terms of marketing analytics that contribute to the factor of a particular category that you want to identify for your cases. So you can use this in many, many different areas, like whether this person is going to buy or not buy, whether the person is going to default on their credit or not default on their credit, or whether the person is going to have a good perception about your company or bad perception about your company. So thank you very much for watching this video. I hope you've got enough information out of this video, and I'll see you again soon. Bye.